We've got a function f with domain here, defined by this value, and g domain here, defined by this value. Write down the domain and range of f of g, and solve the equation f of g of x equals 12. So I've summarized everything here. Let's have a look at it then. So let's just, in our mind's eye, I'd just like to draw a picture of these things. So 3e to the 2x is easy to draw. The domain is minus infinity to infinity, like so, and that's f. And then g, for example, is the log function, so that's only valid for the positive reals, isn't it? And it just looks like this, doesn't it? And this is the g of x function here. So this would be g and this would be f. Now with those thoughts in mind then, we should be able to write down the domain and range of f of g. So domain of f of g. Okay, well the domain of f of g would be, because f of g of x is equal to f of g of x. So the domain of f of g is simply the domain of g of x, isn't it? And g of x has domain 0 to infinity. So the range now of f of g. So if you look back at this now, the g of x, the domain was 0 to infinity, but the g of x here, the range of it is minus infinity to infinity. So these range values feed into the domain of f, doesn't it? If you look at this whole thing. So the domain of f there is covered, so the range of f will come out from the composite function, and the range is 0 to infinity. So that's A. B. Solve the equation fg of x equals 12. So fg of x then is equal to f of g of x, which equals f of g of x, which is log of 4x. Let's write that in. And it's f of this value here. F sends something to 3e to the 2 times something. So it's 3e to the 2 times the something, and in this case it's ln 4x. There's our composite function emerging. Okay, so that's 3e to the 2 log n 4x, and that equals 12, doesn't it? So that tells us then, let's try and tidy this up, e to the 2, bracket can be removed, it's just 2 lots of log n 4x, isn't it? Is equal to, move the 3 from times down to divide, 4. Now to unwrap the log, I'd like to get rid of this 2. To get rid of the 2, we'll move it to a power. So that tells us now then that e to the ln of the object here, 4x, all that squared, because that's how the 2, using properties of logs, it can be moved down to here, or back up to there. That equals 4. Now we've got these adjacent to one another, they cancel each other out. E and the logarithm, one is the inverse of the other, so we're just left with 4x squared. So 4x bracket squared equals 4. So that tells us then 4x times 4x is 16x squared equals 4. And that tells us x squared equals 4 over 16 is a quarter. So when you square root, you get x. Square root of a quarter is a half, plus or minus. But because the domain of the function in question is only the positive reals, the x values that we work out, we only want the positive real solution, don't we? So we discount the minus a half solution.